Okay, welcome back again with me, guys. We would like to continue our previous topic, our previous deep dive for the first chapter about the INIChains and the ecosystem and what INIChain brings. So, refreshment again. Previously, we had deep dive started from the Twitter. So, we found their link tree and also their website. And then if you don't understand something technically, we can ask to the Gemini or another AI and etc. So yeah, for the refreshment, for the bridging before I go to the second video of the series, I would like to remind about the previous thing that we have learned in the chain. Any chains, we might say this is the fastest, safest, and smartest next generation blockchain network. Because of what? Because it not only bring transparency, but also it bring the privacy. Previous one, we have talked a lot about the transparency and moreover the privacy, the importance of the privacy and why it's a matter to Web3 life. So yeah, and before we have talk some content about the InitVerse introductions and then a problem statement and etc. But we will continue right after few sentence or a few pages that we have read over here. So let's refresh for some interesting things over here. We can find InitVerse introductions. I would like to remember to you guys about these things. InitVerse is an innovative ecosystem dedicated to advanced Web3 development. It aims to provide comprehensive support for enterprise grade and the apps of course developers of the high performance infrastructures, cutting edge technology that fostering prosperous decentralized future. The core of infrastructures of InitVerse and INIChain is high performance, stable, and secure smart chain that pioneers of the integration PFHP fully homomorphic encryptions offer the service. Technology into the EVM. Okay, we would like to rephrase again what is TFH EVM? TFH, we might say, is the cryptographic methodology to make ledgering or transactions. It's a keep it transparent but highly private. I mean, it's a really bring the privacy. Like we can see over here, standard source for homomorphic encryption, especially the high efficiency of a type fully homomorphic encryption. FH8 is a cryptographic primitive that allows computations performed directly on encrypted data. So for refreshment, it started with encrypted data. We're going to understand about the encrypted data without decrypted. Okay, so it's mean we don't need to decrypt it first. It's mean we eliminated the another step to make it private to make it safer. The result of a computation remained encrypted when decrypted. It's the same as if operations had been performed and the original unencrypted data. So this is really interesting just because we face that InIChain solve about the privacy by eliminating step from encrypted data. They don't need to decrypt it at first to make the transactions, just because it's eliminated the process. This is a very interesting. So you can find over here is the pillar of the InitVerse SaaS platform provide low-code development and support to support developers, enabling them to seamless and rapidly create and deploy the apps and InitChain. So it's a cutting edge technology that eliminated process for developers. They make a simplified everything, the step for developer to deploy the apps. This not only significantly reduce developer costs, of course, yeah, Definitely, just because this really advanced, it's gonna cut everything cost about it. Cost for enterprise will also further enrich the InitVerse ecosystem by this methodology, cutting all of every cost and cutting the process and make everything so really advanced. So this not only safety can reduce development costs, enterprise will also further enrich the InitVerse ecosystem. Through this ecosystem, nodes contribute to network while earning stable token rewards. Project teams drastically lower developer costs and accelerate innovation. And user enjoy a diverse application ecosystem and can actively participate in government and decision making. Okay, this multi-stakeholder synergy creates a positive flywheel effect, driving continuous growth and innovation in our Web3 space, and ultimately building a vibrant and decentralized future. So interesting. Problem statement we can find over here. Point number two is a problem statement. The privacy transparency dilemma. In the current blockchain's development, the technical and practical challenge faced by public blockchains significantly impact their widespread adoption in Web3 applications. Sure, of course, by you know, technically confusing for developers, many stuff, bunches of the complicated things to do. It's gonna make it's a become a barrier. We might say it's a become a barrier for the entry of to the one ecosystem. Not only hardness coding language, but also their structures. If the SDK provided by the chain and not making easy to develop, of course, it's gonna be problem. Then INIChain solve this problem. And then web recap we might see over here any change aim to address this bottleneck, enabling Web3 application to be utilized more broadly at a scale. Firstly, the balance between privacy and transparency has long been a major challenge in blockchain technology. Okay, this statement, the balance between privacy and transparency, uh, has become a major problem, a major challenging in the blockchain technology. Like I said previously, once a blockchain has transparency, of course, the privacy become one of the major problem. Like we saw it in our account previously in Bitcoin, we see over here the transparency, the transactions, or this is the process of transactions in Bitcoin. You can see over here. This was the transactions happen in the blockchain in the Bitcoin blockchain, and then this is the transparency. Of course, we know the amount or everything that transferred from one wallet to another wallet, but also the the privacy sacrifice just because they can reveal all of the holders over here. It's gonna be something. Yeah, one of the easiest happen in most of a public blockchain. So therefore, by this advancement of the InitVerse, they provide to solve this kind of a problem. It's a very interesting. So as a core characteristic of blockchain, decentralization and transparency are considered to the key establishing trust to ensuring data integrity. We can see over here main core of the characteristic of the blockchains. Most of the blockchains are decentralization and transparency. So one of the considered, we consider K the K is one of the both of them considered as the key to establishing trust, ensuring data integrity, which is also the sign principle of the mainstream public blockchains like Bitcoin and Ethereum. This fully transparent design allows anyone to fit transaction histories and fund flow, helping to build an open, trustworthy network. However, this kind of transparency brings privacy. So, like I mentioned before, we can see over here the transactions process on the Bitcoin blockchain, but also the privacy is not be it's open. It's mean they fully make it who's holding and then when what institution and etc. So it is one of the issues, bro. Of course, anyone whales or even like us as a retail investment. Of course, we don't want to reveal our status holding, like how many we hold, like how much they hold, and etc. So of course, privacy is for the key one. Is the important key that I can say. So for many applications, like scenarios requiring privacy protections, okay, we know that transparency become a risk. In a practice, business and individual users do not want private data exposed to the public, okay, especially in applications involving industries such as finance, healthcare, law, law, where the demand for the data privacy is extremely high. Yeah, so of course, the kind of the data like finance, healthcare, and law, and etc., or like a government and etc., or many kind of the secret data, like a government ID data, it should be kept privately and should not to be revealed. Okay, and then at the same time, in the AI era, many applications rely on the large amount of data to achieve more precise model training. So your data, your privacy is really important. For what? Is it definitely for maybe I can give a such use case in AI. Example, AI can train your data and provide it as like what they use. Of course, it's gonna be dangerous if our data is publicly open, and then it is so for of course gonna be challenge to most of the blockchains happen right now, and the most of blockchains that's available right now. So however, this reliance on data also brings challenges related to the privacy and security. Improper handling of data collections usage might lead to the personal information leak and then trigger trust crisis. So, when misbehave of the blockchain, misbehave of the data used for something, uh, something bad, I can assume like you know, many hackers trying to take the data from governments, I mean, or something like this, that they're gonna sell that data. It's really, really one of the biggest problem happen. So just because most of that ever happens, seriously, it's gonna be a trigger the trust issues on it. So current public blockchain like effectively privacy protections means over 90% of the transactions potentially involving data breaches. Of course, it's going to be 90% of the transactions potentially involving data breaches. Make it more easy to reveal. Make it easy to trace user through the transaction history. This prevent blockchain from meeting the needs of the certain application scenario, and we compare it to the widespread adoption. That's it. Moreover, the difficulty of the integrating on-chain and off-chain data is another major challenge for most of blockchain applications. It is the statement is really interesting. More of the difficulty integrating on-chain and off-chain data. Like we know, Most of the blockchain storage the data is not only on chain but also off chain. By these things, yeah, our data might be used for something bad. It might be mislead of using the data, and then it's gonna be, you know, it's a very dangerous for us as to live in the Web3 industry. So many blockchain applications rely on off-chain personal privacy sensitive data, such as KYC verifications. Okay, we sometimes find that uh, public blockchain, like some of the public blockchain, they're asking for KYC verifications, and also they when they storage it is one of the central, and then it's the privacy is publicly open. It's going to be dangerous. User identify information, the user identity information, and the financial data. The integration of this off-chain data involves not only access to the cross-chain and the third-party service, but also handling a significant amount of the privacy requirement. This is it. This is something really, really bad in most of a public blockchain uh, who's not cover the privacy. For INIChain, it's really good just because it's solving that kind of the problem. Transparency, yes, but still transparency, and also privacy. In the Web3 world, in the UK, competitions and the market authorities achieved data authorization in exchange in 2016 through centralized APIs, allowing consumers safely enjoy the personalized and diverse financial services. This wave of open banking created more innovative services, balancing transparency and privacy in the traditional financial sector. Returning data using use the right to consumer. However, the security and the authenticity of the data exchange still rely on centralized authority and government control. So definitely we understand in the centralized things like Web3 stuff that we know Web2 is a highly, you know, it's a highly restricted the data controlled by one entity. Example like government data, they control it, and then about the identity data, like a bank, they collect our data, and then our job, our amount of salary, and etc. They collect it and they save it. By controlling that thing, so Web two becomes something really, really centralized, and sometimes we found trouble over there just because the leaked data used to expose in expose in the marketplace. The data, the centralized data, often to be exposed in the centralized government things or something centralized. That's happening in Web2. So in the decentralized Web3, when on-chain application need to use their identities to pass the verification data for transactions or authorizations, how to securely perform on-chain, off-chain, with third-party data interaction while ensuring user privacy remains a technical challenge. Currently, data on-chain and off-chain is going to be for Web3 users most it's going to be face a really technical data just because type of the on-chain storage in the blockchain, which is storage, ledgering storage in public chain. It's open. The people can access the information, but the privacy sometimes or most of the public blockchains currently can open it. It means we can know that the technical issues between sparring of this data is going to still remains become the technical challenge. Although currently privacy technologies such as zero knowledge proof (ZK) have achieved breakthrough in the privacy protection, significant limitations remain. Okay, don't forget, if the most of the users right now in the public blockchains and like ZK proof, uh, ZK is one of the method that the user or peer-to-peer still using, still do transactions without knowing the the things what inside, just because they don't need to be open the data, but only using for GK proof. But it still have a significant limitation remain. The computational cost of the technology is high, and the verification processes require a large amount of the resource. Of course, by the thing, ZK still remain limitation remain. Existing privacy protection solution in case performing overhead by an leverage average 240 400%, which greatly limits the application in the large blockchain. Furthermore, Zika proof lacks scalability. Okay, we know that Zika proof is the lack of scalability, making it difficult to maintain efficiency during extensive on-chain transactions. In on-chain transactions, ZK it still remain lack of scalability. Okay, that's interesting. Therefore, they cannot meet the dual requirement of the performance and the cost for enterprise level application. So that means ZK limit the things. They limit the things. If we want to secure the data, but it's a really high cost. If we want to something really good performance, they really costly. For enterprise level application, this limitation highly the need for the more scalable and lower cost solution to achieve privacy protection. So this one, ZK is limiting this user just because of the protection solutions. The gap between one problem solution by the ZK. If if a user want to, I mean, the ZK itself, if going to be private or secure, but they face something requirement and with I mean with the cost efficiency that we highlight from this paragraph, cost and the performance. They cannot afford the price of the cost of the transactions and also the performance of the transaction. ZK limitation. Meanwhile, the scalability and the performance issues in the public blockchain also deserve attention. Okay, as a transaction volume increase, most public blockchain face network congestion. Okay, we find in a most public blockchain like Ethereum. We find in Ethereum, the public when the performance issue. Okay, in Ethereum, performance issues are one of the bigger things problem right there. Just because when the transaction going tight and really crowded over there, of course, scalability is the one of the problem. The transaction performance transactions really become a big question mark for the user. For those who already who ever do most of the transactions in Ethereum, of course, when the face congestions just because the blockchain is a very crowd, many people are going to transact, so everything is going to be expensive. So As a transaction following request, most public blockchain are faced with next recognition, leading to slower transaction speed and rising the speed. This has happened in Ethereum. This this scalability is to limit the capacity of the blockchain in application, particularly in the financial transactions and the games that require high transaction frequencies. Okay. Although some existing layer 2 solution can overload part of the transaction burden, they still face issues with security and the research of consumption. Okay. People say most advanced say that Ethereum solution for scalability is the layer 2. But we have to remember the simplest analogy for the simplest analogy for Ethereum is layer 1, and then most of the layer 2. It's the analogy like this. Imagine New York is the the Ethereum. We can say New York is the Ethereum. Okay, when it's a crowd, it's really messed up. Ethereum, we imagine that we can put analogy like this. Ethereum, we can say it's the same like in New York. When layer two, it's the same like supercar or hypercar on it. When the traffic so crowd in the New York City, just because so many people doing activities on it or doing transaction on it, and layer two, that's it said ring high performance like a fast and cheap, but you cannot drive that type of supercar or hypercar fast in New York just because the crowd. This is the analogy. So uh, they still face the issue security and the resource of consumptions, of course. Also, improving scalability often requires sacrificing decentralization. Remember this one. Improving scalability often requires sacrificing decentralization. Like, Solana. Solana is a really high performance, security, and really good, but is sacrificing the decentralized by only 1.2k validator right now in the Solana. They sacrificing the centralized, making the coordinated development of high performance and centralization as continuing technical challenge. This is what happened currently in the most public of blockchain. It's interesting. So, to address the above problems and promote the development of the blockchain industry, INIChain perfectly integrates TFH fully homomorphic encryption of resource technology with EVM, interesting, achieving an effective balance between privacy and transparency and innovative way. Okay. Firstly, TFH allow computation on encrypted data, ensuring that sensitive data remains private during processing. Okay, the system is select. We can assume that the system or the engine of this architecture ensuring the sensitive data remain private. This is something that really interesting and must be highlighted. These features of the encrypted computation is particularly suitable for application scenarios with high privacy demands. Hmm. So yeah, the feature of the encrypted computation is particularly suitable for application scenario with high privacy demand, especially in financial and DeFi application. Okay, any chain design consider the differing privacy requirement of the various application. Okay, the any chain design consider differing privacy requirement various application. Okay, recognizing not all data needs encrypted processing, or recognizing that not all data needs encrypted processing. It's mean the engine of the INIChain is gonna select it all of the most data, which one is must be encrypted and which one must not be encrypted. Interesting. It just can select it by itself. So especially during encrypted processing, for instance, in a GameFi application, attributes such as character level, represented as a public NFT, have lower privacy requirement and do not need TFHA. Okay, this allow network resources to be allocated more effectively and significantly improve processing efficiency. Yeah, it's a very advanced method that the technology of the TFHFPM can qualify between the data which is very secure, and the data must not to be encrypted and encrypted. Such this is the example like public NFT, right? It's interesting. In addition, unlike Bitcoin and Ethereum's proof of work mechanism, which only periodically adjusts the overall network total hash rate and block generation speed. So in addition, unlike a Bitcoin and Ethereum proof of work mechanism, which only periodically adjusts the overall network total hash rate and the block generation speed. Okay. In INIChain optimized the PO proof of work consensus mechanism by adopting a dual layer dynamic adjustment mechanism to meet diverse demand based on the network total hash rate distribution and the block privacy. INIChain dynamically classified data block with high privacy demands require higher computational power during mining. ASIC specific chips can significantly accelerate blockchain generation, improve efficiency, and earn better block reward. So, this is descriptions about how they manage to qualify the high, really private data and then low private data quality. And then this is processing by the process of the validations. Because they can solve this by this method. It's interesting. It's been the blockchains can like qualified between high top priority privacy and less priority. Which means it can geniusly spare it between of them. Hmm. Okay. On the other hand, general blocks are kept at a lower difficulty level, allowing participation using general-purpose devices like CPU and GPU. This reduces the participation threshold and curbs hash rate monopolies and achieve a decentralized mining model similar to Bitcoin. Okay. Okay, we would like to highlight this one. On the other hand, general browsers keep a lower difficulty level, allowing participation using general purpose devices like CPU and GPU. This reduces the participation threshold. Okay, by the problem solved by this thing, and then it's gonna decrease and reduce all of the miner, all of the nodes uh, to achieve decentralized similarity with the big Bitcoin. It's interesting just because the method is really new technology, new we might say like new mechanism software. Furthermore, the Versa has integrate algorithm flexibly adjust encryption complexity and computational threshold according to the privacy demand of the data within the block. INIChain Elastic architectural design strikes a balance between decentralized mining, performance demand, ensuring privacy while encouraging burden node participation and providing flexible support for various application scenarios. This dual-layer dynamic mechanism complement each other to safeguard the security, efficiency, and fairness of the blockchain network. Okay, this method, I mean, we might say this simplified, like Bitcoin, they really has a really good security, and then uh, but the cost of the security and it's of course the privacy, right? Like we can find for. So this method by INIChain using intelligent algorithm to adjust encryption complexity. Oh, it means yeah, INIChain engineer has the method to adjust encryption's complexity between the nodes. It's been they classified this is important data, which is not really that important. It's interesting. Although innovation in the public blockchain technology continue to enhance privacy and security, having a robust technology alone is not always sufficient. The feasible practical application of their ability drive ecosystem growth and the key of the success. Okay, the to achieve this, project teams can leverage InitVerse SaaS platform to flexible encrypt specific field using TFHA to protect data privacy while meeting the needs of the specific application. Okay, it means the flexibility encryption model. It's bring you know, is bring like simplicity, bring simpleness to the blockchain itself to processing the data based on what needs. This flexibility not only improve development efficiency but also accelerate ecosystem growth, allowing more projects to quickly and securely join the advanced comprehensive development of the Web3. Okay, this is from all of these explanations. It's a very interesting, and then we get the point from that things by from all of the chapter 1 and chapter 2 that I explained from the first day bring what they bring something that we have to highlight is the using TFH fully homomorphic encryption. This method can solve and can intelligently classify between a high security demand of the data and then low security demand of the data. It's mean they classified it. By classifying these two things, it's a make the blockchain simple and more easier and make the performance or the processing of the transactions become smoother and become more safer just because they do not need to encrypt all of the data on the stuff on all of stuff they don't need to encrypt all of the things only classify which important which are not really that important to be classified and then to be encrypted. It's a genius. So the next point we can understand over here by all of the simplicity happen by all of simplicity provided by the INIChain, it's going to be something easier. It's I mean make the developer easier to deploy and project to securely joins the advancement of the INIChain's ecosystem blockchain. it's interesting. So yeah, maybe from this chapter 2 will end up here, and for the next chapter we would like to discuss, and we would like to that deep dive again and in the next video. So thank you guys. Hopefully you enjoy my explanation, and see you.